right, thank you. Can you hear me okay? Excellent. All right. So actually to the last question for Julian's, this is hopefully very, very relevant, so we'll see. So yeah, this is about Bomb Squad. It's a project that we're working on to hopefully help tone down some bad events that we'll talk about in a moment. First up, who am I? So I'm Cody Boggs, nicknamed Choney. If we have time, we may tell that story. I don't know. It depends. I'm an ops nerd for about the last 8 years. Been lead of ops for Fresh Tracks for about the last year, a little bit more. I'm obsessed with metrics and most other things observability related. I like to pretend to write code. My team's helping me to be less pretendy and more actual, writing. And I break all the things because that's apparently how I learn best. So we'll go from there. So what's on deck? Let's talk about what is cardinality. We've heard it several times today, but we should get a better feel for it. What does it mean when it explodes? It sounds bad, and spoiler alert, it is. Who cares? We need charts and graphs so we can kind of back up some of my claims, and then we'll see how well we get through a live demo of Bomb Squad. So first, what is cardinality? We talk a lot about high cardinality and low cardinality. It's simpler than it seems. Sometimes your birds are too high, and sometimes they're too low. So that's my talk. Thank you so much. I hope that's the only bad joke in the talk. We'll see how it goes. More generally and more seriously, it's just the count of a number of things in a group. So in this little fake set of things of B42 and tree, we have a cardinality of 3. A little bit more scoped to this talk. We're going to talk more specifically about how many discrete series there are for a given metric. I know that, as to Julian's point, it is indeed series all the way down. We're going to flip that script a little bit and think about it more semantically as a metric is a thing that contains series, so we'll talk more about that in a bit. But for my little fake series here called CPU, if I had one label called host and 3 distinct values for it, I have a cardinality of 3 for my metric CPU. So let's settle on terms, back to the comment that I jumped ahead on. So a series, for anybody who's forgotten already, is just a discrete pairing of label names and their values. For the sake of this talk, at least, a metric is a set of series whose name, special label, match. So for instance, API requests, CPU on the last slide, so forth. A cardinality explosion, or a high cardinality event, as we'll talk about a lot, is a really sharp increase. It's a really sudden blow up, basically, of the amount of series that are associated with a particular metric. And an exploding label, as fun as that sounds, it really is just a label whose value is being set to very, very high cardinality values. So, and it's disproportionately high compared to others, and therefore makes the metric under which all those series exist explode. We'll see more of this as we go through. So let's unpack this idea of explosions a little bit better. First off, I didn't have exploding birds in the first slide because it seemed a little violent, so we won't go there. But again, this is a really rapid inflation of I have a metric, and suddenly it got a ton of series created for it, and generally it's a sustained issue. Some of the things that can cause that, the first two aren't necessarily bad in and of themselves, and they tend to not be a prolonged, sustained explosion. But if you have really prolonged extreme pod turnover rates, somebody just keeps spinning things up and back down more often than you'd expect, this could cause at least a short-lived and less severe version of this. A highly elastic workload where suddenly it's churning through tons and tons of work that you didn't expect or potentially out of character for it. You could end up with, again, potentially, hopefully, a short-lived version of this. But most commonly, and the most devastatingly that we see, are actually the bad code deploy, wherein a well-intentioned engineer, either knowingly or unknowingly, deploys a code change where one or more metrics ends up having some really high cardinality data, highly unique data like request IDs, timestamps, which we'll use for the demo, into a label or more than one label. And so suddenly that metric starts to explode. Like I said, this seems to be the most common, and it's the most painful. The magnitude of these tends to be very huge, and they tend to be really hard to track down. To one of the questions earlier, it's not always easy to figure out what metric, who's doing it, where it's coming from. So we've tried to ease some of that. But first, why do you care? So basically, you can catch everything on fire. The first one up is kind of actually the lowest priority one, so we'll get it out of the way, is that during and after these kinds of events, the data that was affected by this explosion borders on meaningless, because typically you get a single data point that was valid at some point, and then it just sticks because it keeps getting exposed by the exporter that pushed it in the first place. But more importantly, it will burn your Prometheus down in a hurry, as we'll see in a moment. So query times, scrape times, all of the metrics that we care about in a Prometheus server will start to look terrible, and you'll end up losing your ability to investigate what took it down because you would typically use Prometheus to find that out. So, and then also downstream services, right? So at FreshTracks, we push our agent tree is effectively just a Prometheus instance with a very bespoke configuration that ships data to Cortex, which is our backing store. That's backed by Bigtable, and neither of those pieces really likes these explosions at all. I say neither. All three of those pieces, if I could learn to count, really dislike that behavior. So obviously picks or it didn't happen. So this is a standalone Prometheus instance that I used for testing this and building some graphs. This was simply scraping one workload, which was 20 pods of my little toy app that emits around 100 new series per second. So generally simulating approximately 2,000 requests a second on some application. And I don't know, we won't go too deep into these particular graphs, but if you've ever seen these metrics or are at all familiar with them, you'll know this is the last thing your Prometheus sees before it dies a fiery death. So this is a bad place to be. More fun data, this is actually real data from one of our incidents in production. So as you can see, we kind of had a nice steady state for ingestion for a while until one of our customers had a code deploy go out. Their agent started shipping us extremely high cardinality data because there were request IDs being stuck into a label. And so our ingestion path started to churn. Total time from front door to the back end started to get to unreasonable levels from nanoseconds to almost a minute. And if you look at the Bigtable graph, that one was really fun. Simply because not only did the request rate climb dramatically for the backing store itself, but these were very, very tiny writes, as it turns out, over time, and it did not like that at all. So you can really churn bad when these things happen. This event actually is what prompted me to start working on Bomb Squad and prompted this talk. So on that note, what in the world is Bomb Squad, other than a really awesome name that I didn't come up with, sadly? So it's basically just a small little binary that's intended to be run as a sidecar to your Kubernetes-hosted Prometheus, at least at this point. It bootstraps itself into that Prometheus with a recording rule that it uses for doing the detection. It starts to watch for exploding metrics. When it finds one, it figures out, okay, which label is contributing the most to this explosion within that metric. And then it will insert a silencing rule, which is just a generated relabel config. After some indeterminate number of steps where this has been remediated and the new code has been deployed and the explosion is no longer taking place, there are some CLI commands that we'll look at here in a moment. So let's see how well we can do this. Can you still hear me? Good, thank you. All right, so we'll drop out of here. There we go. All right, make this bigger, say when. Is that mostly legible for everybody? Great, excellent. Bear with me, I use Tmux, so I'll be splitting this into a couple of panes here in a moment, but if you get lost, tell me to stop and I'll rewind. So all I have running here is a Minikube instance. So I have two pods. One is called StatSpitter. That's the toy app that I mentioned. It just, when I ask it to, will start to generate approximately 100 new series per second. And then we have Prometheus, where it's Prometheus proper. There's the ubiquitous Jimmy Dyson config map reload sidecar, which is kind of vital to this whole process. And then there's Bomb Squad running as the other sidecar. Excuse me. So on that note, let's go take a look at the Prometheus UI, and we can kind of point out a couple of the things that I mentioned earlier. That seems fairly large. So if we go look at the existing rules in this Prometheus, this is the recording rule that Bomb Squad bootstraps into the Prometheus instance. It's not a terribly complicated one. This is actually using the label replace function that Julian mentioned in his Q&A. And it builds up this card count metric that we use, which has, thankfully, one label, which is the original metric name that it was calculating. And it just tracks what is the cardinality of any given metric in the system at that point in time. If we want to look at a slightly more interesting example that's at least pertinent to the demo, we can go look at it for our test metric that we're going to be watching and destroying here in a moment. So we just have this little test gauge from StatSpitter, and currently its cardinality is 11. We can look at that over a little bit of time and see it's been nice and stable, which is great. I just have some really contrived label values that I've pushed in there for now. What we can do is make this explode, watch Bomb Squad silence it, remediate the problem, and then watch it all come back after we've explicitly told it stop silencing this. So we will go back over here, if I can remember all my steps. Let's go ahead and open up the logs for Bomb Squad. By the way, if you are not using Stern, you're missing out. It's great. You'll never watch a single log from one container ever again. It's good stuff. So we've got the Bomb Squad logs on the left. On the right, let's go ahead and toggle this so that we will have StatSpitter start to spit out new series at a rate of approximately 100 per second. We should see that take place pretty quickly. Yeah. So as you can see, this is only 100 new series per second. It's going fairly quickly. We're going to look at some data, if we can, in a moment. Let's take this guy and just look at it on its own before it gets too slow to query it, because it will very quickly. See how it's already churning when there's nothing else happening? It's good times. So if we look through here, I meant to take some of these labels out, but fortunately we have a find function in the browser. Cool, so this is the label that we're stuffing all of these unique values into. You can see I had nice static values until at some point I started putting in boom underscore and a timestamp. Boom just seemed important for the Bomb Squad name. It's good times. So these are bad, very, very, very bad. Don't ever do this. But when you do this, hopefully we can help. So as you can see, that's starting to blow up fairly quickly. We're actually going to just go back to this page because all the data that's on that screen is not rendering terribly well. Let's go back to our cardinality watch. And you see we're at a pretty high value already. If we shrink this back down to a more usable time frame, you can see how quickly this is going. If we jump back over here, however, we see, wow, that was touchy. Here we go. We can actually see that Bomb Squad has already detected that. And if I had thought about it, I would have switched back sooner. And you would have seen that it only took a few seconds to find it because I have my eval intervals turned down really low. But basically it finds it and says, hey, there's a label exploding. It's called high card. And it's exploding on this metric name currently. I didn't find the silencing rules that I expected to find in order for this to not happen, which kind of makes sense. So I inserted it into every scrape config because I can't guarantee that I can't necessarily guarantee yet that you don't have multiple scrape jobs grabbing the same metrics from the same target. It would be silly to do that, but it does happen. So we just go across the board. We still detect it for a while because we have to wait for an eventually consistent mechanism of Kubernetes, which is the config map reload inside the pod, to take place. But then that way, the config map reload container will hot reload the Prometheus config to make our silencing rules take effect. So if we go back over here and we look at this again, you can see that sure enough, we actually cranked our cardinality way down. Interestingly, we dropped below what the original cardinality was, and we'll see why here in just a moment. But you can see how quickly this escalated, right? In this course of less than a minute and a half or so, right around that, we got up to 8,400 distinct series underneath this metric, almost all of which are useless, and we're probably starting to put everything under considerable strain. What we've done is we've taken that high card label, and the values for all of those now are simply the word, make sure I don't mess it up. This is gonna hurt. Anyways, we basically replaced all of those timestamps that are still being emitted from StatSpitter with the string, I believe, BS underscore silence. Which, by the way, Bomb Squad shrinks down to a really good name. It's great. Yeah, so if we come down here and look at this, yeah, so here's the static label that we've got. And so this is where we have some other label that's distinct between these two, but the one that's exploding, we've replaced with a static string. You can call it whatever you like. But that cranks the cardinality down. Needless to say, this is going to really, really, really mess up any dashboards that are monitoring or watching this metric. If you're displaying it, particularly by way of using any of the exploding labels, things are going to look really bad. And this is a super subtle way to have to go find out that it got silenced. So instead of making you just dig around and hope that you can figure out what happened, Bomb Squad does expose a label or a metric to indicate what label is exploding and what the distinct values have been at any given time. So ideally, you would probably alert on this to say, hey, don't do that anymore. Or in our case, we would at least have this emitted back to us so that when this happens and we see somebody's agents die off, we can find out why and who it was. So all it does is track label and metric that are exploding, tells you what the cardinality count was at the time that it detected it, and before the silence actually took effect. So these should generally line up pretty closely with that card count metric. So we've done this. We've talked to the developers and said, hey, you did a thing. I'm sure you meant well, but you broke all of the things. It's probably me. I need you to go fix this and redeploy. The redeploy is crucial because otherwise the old instances, if you just toggle it the way that I did to turn it on, and then unsilence the metric, then you're going to still have all of the old exploding series in the existing registry from the old running instances. They'll get rescraped immediately. Bomb Squad will see it. They'll silence everything. You'll say bad things about me and open all kinds of GitHub issues, which is probably not what we want. So the redeploy is really crucial. It has to stop and start again. We have to clear out that registry. So we'll simulate that by, pardon my shortenings of words, I don't type well, so we will go ahead and just delete our stat spitter pod, which will simulate a nice little redeploy. It'll start back up, defaulting to not an exploding state. We'll come back over here and say, cool, that's great, but now how in the world do I go through and fix this so that I can get my labels back and my dashboards aren't awful anymore? So in that case, we've added a nice, fairly handy, aha, it worked, little CLI that you can use. So you can run BS list, and you'll get a very graphite-ish representation of what metric and label name are exploding and have been subsequently silenced. So the format's funky, but it makes for a nice copy-paste. So there it is. Once you've confirmed that everything should be better, and you're confident that it won't explode again, you can say, oops, jumped the gun. All right. You can say BS unsilence, paste in that value. It will delete the silencing rules from every scrape config that it found. We can look over here in the bomb squad logs on the left again and see that it's resetting the metrics for itself. Let's go back to Prometheus and just look at that momentarily. Get this down again. So you can see we went ahead and just reset it back to 0, ideally to give you the benefit of the doubt that your devs really did fix the problem and that your alerts can hopefully resolve. Seems like a good plan at least. So there's that. We should also then be able to see our cardinality come back to a nice stable value of 11, which we do. So there's that. You can see it went from 2, eventually it dropped to 1. I haven't figured that part out yet, but and we went back to our 11 stable values. So we've effectively kept the original Prometheus instance from just dying in a fire, and we've been able to automatically suppress that particularly bad behavior and still give you some kind of visibility into exactly what happened with what metric. You can add whatever labels you want to this. There's probably some things that need to be whitelisted, I assume. We haven't quite implemented that yet, but there's a lot of potential here, I think. So let's see. I think that's all there was. So on that note, that's Bomb Squad, and that's me. Hopefully I didn't rush that too terribly bad. This is open source, by the way. You can go here and go grab it. It's a bit proof of concept-y right now, so PRs are welcome. But that's it.
Thank you. So, questions?
Yeah, so great talk, and actually thank you for that, because probably you saved all of us and I think us from writing the same thing, because I think it's a must-have. And speaking of that, when we can see all of this inside Prometheus without any sidecar? That's my question.
That is a fabulous question for the maintainers. No, absolutely. So, no, we're actually pretty excited because we do try to contribute back to Prometheus whenever we can. This is something that seems pretty cool, and yeah, if we could actually potentially insert somewhere in the scrape path, this may become more efficient, or at least a quicker trigger. So yeah, it would be a neat project to take on for sure.
Any other questions? There we go.
Thank you for the talk. So what if the cardinality, high cardinality comes from the different label names, not from the label values? Is it an issue, and can Bomb Squad deal with this?
That is a fantastic question. That is not something we've tackled quite yet. It is definitely a possible scenario. We've not seen it in production yet, but it is one that we thought about. Just haven't quite figured out an appropriate approach yet for that. I don't think we can access label names the same way that we do label values in the relabel config, so we may have to get creative with that.
Yeah, different metric names is actually one that happens every now and then.
Yeah, true.
Especially
Fortunately, it's just a label, but then it kind of does break the semantic picture that I just drew. So, yeah.
Hi, thank you for the talk.
Thank you.
Seems really useful, but what about for those of us who maybe aren't using Kubernetes just yet? Maybe Nomad, or in the case of monitoring a static deploy?
Sure. So the current implementation is very much only in Kubernetes, just because that's our stack and we needed to make it work for us. That said, conceptually, there's no reason it can't work on other orchestration systems or potentially even in a bare metal environment. You would just need to figure out the auto reload of the config in Prometheus bit, I think, is the key thing. So I'd love to see it expand out, though, and be much more broadly applicable than just Kubernetes, because it's definitely a situation.
Hi, thanks for the talk again. It seems that you're modifying the configuration of Prometheus on the fly, right?
Yes.
Cool. Do you have any issues when you've done this that people might deploy Prometheus or like make modifications to the rules?
Yeah, so I believe we did manage to implement before this talk. I'll have to go back and check, but Bomb Squad actually keeps its own config as well. Oh, so sad you can't see my pretty slide. Anyways, Bomb Squad has its own key in the same config map as your Prometheus config, where it tracks those metric .label name bits, and it actually has a base64 encoded copy of the rule itself, so that it can actually rescan the config on startup and say, I know I should be silencing this, am I? And then it will reinsert the rule if it needs to.
Perfect, thanks.
Thanks for the talk. Can you catch metrics that disappear, like if on which scrape I get a new set of labels and the old one is gone, like I get the current timestamp in my label, for example?
Yeah, so is this similar to the unique high cardinality label names question? Oh, yeah.
Oh no,
yeah.
this is about if you have in the label the current date time of the scrape, for example, so that the next time you scrape it, then you have a new set of labels, a new set of metrics, but the number is the same, but just like they're every time different.
I see. So yeah, the cardinality has shifted dramatically, but it hasn't necessarily continued to climb. It stays static on the card count. Yeah, I haven't accounted for that one yet. That is an interesting case, though, that would be very painful, I think, to diagnose without something automated. So. Who else?
Any more questions? It's almost as though you want to go to lunch early.
Yeah. Thank you so much.
Is that everyone?